Alrighty. Good. At this point, it's good night, but I'm gonna say good morning or good afternoon by the time that you're watching this. I wanted to create a quick 10-minute video to keep my word about how to do today's assignment. Okay, today's topic was functions 8.5G, and we kept talking about functions being like a relationship. So here's the first thing that you should have seen. On yours page is going to say function notes. Okay, and here this is the definition of a function. For every, right here you would type in for every x, there's one y. Oop, get rid of that is the mathematical definition that they're looking for on like a STAR test or some other assessment. They'd want you to know that for every x, there's one y. And x can represent different things. So if we called it for every input, there's one output. For every domain, there's one range. For every independent, there's one dependent. Okay? If this wasn't true, it simply wouldn't be a function. But that sounds real technical and mathy. And I don't want you to be afraid of that. Okay? So I gave you an example of like dating. So here's Mr. Heiston now when he was married, or now that he's married. And it says, my heart goes to one woman, my wife. So for every one of me, there's one woman for me. That's a function. Here's Mr. Heiston when he was a dog back in middle school / high school. Okay, my heart went to multiple women. This is not a good thing. Okay, that is a bad example. Therefore, it is not a function. This is not how you want to live your life. All right, this would not be a function because this does not match our definition. For every x, if I was the x, there is not one y. There is one y, two y, three y's. No bueno. Okay, we apply that same knowledge to our actual math problems. For every x, there's one y. So here it says list at least three facts you notice about this diagram. Okay, well I would notice that this one is going to two different y's. It's going to 2 and 4. So that tells me that this is not a function. So right here I would type in 1 it has multiple y's. I would say 3 is 3 is dating 4. And then I would say 5, 7, and 9 are dating the same number. But that doesn't violate our definition because for every x, there's still one y. All right. That's what I would put if I were your age. And so this is a complete one of these sentences. This relation is a function or it is not a function. I would say it is not a function because the one, which is an x, had multiple y's. And as we said in the first slide, if it has, our definition of a function is that for every x, there's one y. Since this x has multiple y's, this whole thing is not a function. Okay, and that same idea for a table. I mean, quite frankly, if I took these two and put them together, I'd have a table. Okay, 4 is dating 10, good. Is there any other 4 dating anybody else? Nope, perfect. 3 is dating 8. It's a function so far. Any other 3s? Yes, Who's it dating though? 8, same number, we're good. 2's dating 6. Any other 2s? Yes, but it's dating 6 again. Okay, there's nobody cheating, and 1 is dating 4. This is beautiful. This is a function. So I list out 3 things I saw here, and I would say this is a function because, I'll go ahead and highlight. Now, this is not a answer key, so I'm not going to give you all the answers. I just want to show you how to do it. Same here, ordered pair. X always comes first, just as it did with a table, and just as it did with mapping diagram. All right, so if X goes first, we have an X here and a Y. So I have X, this one is dating -1. Is there any other number that 1 is dating? Let's find out. Okay. All right. Oh, 1. Who's 1 dating? -6. I thought 1 was dating -1. This is a lying, cheating, no good. Sorry, this is not a function. That's what be professional. This is not a function. So, and again, you need to put out 3 things that you notice and why it's not a function. And the same goes for our graph. Okay? Do not complicate it. Our definition is the same for every x, and x is labeled. This is your x-axis. Little secret, you should never get these flipped because it is always labeled for you. This is your x-axis, and this is your y-axis. So for every x, there should be one y. So let's go here. X at 0, there's one dot at 0. X0, Y0, that's a function so far. But when x is negative 1, there's nothing here, so I can't figure that out. But when x is negative 2, there's a y of 2, positive 2 right there, and a y of negative 2. So when x is negative 2, there are two different numbers. That means negative 2 is dating two different people, and this is automatically not a function. Okay? And once again, you follow the same rules. What did you notice about this graph? And then, or three things. What three things that you noticed? And then right here, why is it not a function? All right? That was the note side. And then we just came over here and applied our knowledge to multiple examples. And during the day, I did the first slide for you. This is the assignment that was actually a grade. Okay? All you have to do is match your data, no matter which way is given. In this case, it's given in ordered pairs. Match it to the mapping diagrams, then match it to the tables, and match it to the graph. This first slide is the hardest slide, and it's the only slide I'm going to do with you. But I want you to notice that slide 2 gives you all the data in a table. So now you got to create your ordered pairs, create your mapping diagrams, and your graph. On slide 3, it gives you the ordered pair again, and you got to create everything from that. Slide 4, it gives you everything on the graph. So for example, it's 1, 0. So my first one here would be 1, 0. Okay, but you got to fill in all these. And then, of course, your ordered pair, your mapping diagram. And here it starts with the mapping diagram. So use this information to create the rest of the data. So here's an example. 0, 0, that means 0 is dating 0. Okay, who's 1 dating? 2. Okay, so I need a line going from 1 to 2. We have a 2 dating a 4. Okay. We have a 3 dating a 6. And we have a 4 dating an 8. Okay. Easy. The mapping diagram was done. 6, 6 we cannot put here because we don't have space for a 6, 6, and it's not here for us. If we were able to write it out, we would just be able to write in 6 and then draw a line going to 6. But we're not able to since we're on a computer. Now, for our table, we just fill in 0, 0, 1, 2, 2, 4, 3, 6, 4, 8. From there, we already have a 2, 4. We have another 4, 8, 6. Oh, here we could technically put the 6, 6 in. Now here, the last part of the table, we need to drag a dot to create the exact same data. We use these ordered pairs to make the mapping diagram, and we made the table, and now we got to make a graph. My first point was 0, 0, then it was 1, 2. So I'm going to grab a dot, put it at 0, 0. Now I need another dot, and I'm going to put it at 1, 2. I need another dot, I need it at 2, 4. Starting from the origin, I go over 2, and I go up 4. Then I need 3, 6. So starting from the origin, I'm going to go over 3 and then up to 6. But of course, I need my dot. Boom. And I need a 4, 8. 4, 8. Okay, that is how you do this assignment. Again, I wanted to keep it short. I want to respect your time. I'm going to go ahead and stop talking, y'all. Make sure you go to attend tutoring hours. You can text me between school times like 8 a.m. to 6 p.m. I'll respond. You can do audio chat in the Google Meet videos every day. You can look at these YouTube videos. I have office hours. I just posted a link on the page. It says Daily Math Office / tutoring hours. That link every day between 11:30 a.m. and 1. I'm available. Okay, I'm here to help you succeed. We only have 9 days left, y'all. Okay, y'all have yourself a fantastic day. Keep your head up. Stay strong. I believe in you, and you should believe in yourself. Okay. Have a great, night or day. Bye-bye.